And welcome back to our last half day of the eighth annual Electric VTOL Symposium. The 9th Biennial Autonomous VTOL Technical Conference is the Workforce Development Session in the Electric VTOL Symposium. I want to thank all of our sponsors, and today's sponsor in particular, Hexcel. We also note that earlier today we had SAE and CAE on our panels, and we want to thank them for contributing, as well as we had some technical talks at the lunch break from Aviation Safety Resources in Carlisle. So thanks to all of those folks and all of our sponsors throughout the week for all that they've contributed into the event. I'll turn it over to Mr. Dan Newman, who is our moderator for today. He's a senior technical fellow and chief engineer for advanced VTOL at the Boeing Corp, and he's going to lead us through this session on workforce development. So with that, Dan, I will let you take it and run.
Thanks, Jim. Welcome for those who are just joining or returning from the rest of the symposium. Excited to have you here. We got a really interesting opportunity. This annual session on autonomous VTOL and these 1 year behind the eVTOL activities that started with the transformational vertical flight out of the Vertical Flight Society and NASA. A lot of traction, a lot of activity, an extraordinary amount of investment and resources on the supply side, and the challenge is execution. How do we get this job done? How do we advance the work? Do we have the people to get there? Do we have the knowledge base? How can we avoid learning lessons? How can we capitalize on those lessons? How can we make sure it's not just lessons observed, but it's lessons learned and implemented? I've had an extraordinary time in this career, and this is a phenomenal time for those just joining and those moving into the career. And VFS has given me and this panel, a great panel, the opportunity to talk a little bit about the workforce. Our goal here is to address the opportunities with the workforce and the challenges. Our esteemed panel will share with you their thoughts and their perspectives. You can see the chart summarizes. I'll give a brief introduction of each. We have a full agenda here. The plan is for about 10 minutes of sharing of thoughts by each of the individuals. That's not a lot of time, but we're squeezing it in. And then we'll have the opportunity to discuss, to take questions, to have the panelists discuss with each other. They all have innovative and creative thoughts, and they're not always the same direction. So there'll be some good conversation, and we really welcome the attendees to engage. I have encouraged the presenters to speak and not just present, to share their thoughts, and in only rare cases using charts, because I want this to be a conversation, and I invite the attendees to participate. And our goal is not only to comment on the workforce and the trajectory for the future workforce, but to identify possible actions that can be taken to better arm or to encourage, enhance, improve the workforce to support all the demands for vertical flight and all the related research. So we'll not only be talking about classic vertical flight technologies, but all those things that are enhancing and that we're bringing to bear to dramatically enhance both capability and the market and the utility. So briefly, Jim has spoken, Dan Newman from the Boeing Company, excited to be the facilitator here. Our panel includes Kathryn Creedy, Future Aviation Aerospace Workforce News. If you were not aware, this is a great resource, particularly on this topic. Dr. Mark Robeson from the US Army, Structures Tech Area Lead. Dr. Nancy Leveson from MIT. David Segal, from Director of Business Transformation from PTC. Dr. Igor Cherepinsky from Sikorsky, Lockheed Martin Company. Dr. Amy Pritchett, a professor and head of the aerospace engineering at Penn State. And then we'll come and open it up to the attendees to ask questions. And with that, in order to provide time for the panelists, I'll ask the other panelists to turn off their cameras and invite Kathryn Creedy. I'll just introduce it briefly, what she said, She's going to share with us how aviation and aerospace education is changing, the many challenges we face, the changes being suggested, the astonishing number of education resources available, and how we need to think differently about the education wheel. And with that, I leave it to you, Kathryn.
Well, thank you, Dan. I really appreciate it, and thank you for having me. I'm an aviation journalist, and as an aviation journalist with more than 30 years experience, I have been covering aviation aerospace workforce issues. In response to shortages, the industry is largely focused on creating pipelines to replace the retirement tsunami already facing us. While COVID may seem as a reprieve, it only compounds an already bad situation because it accelerated retirements that would have happened over 5 years into a single year. The loss of this body of knowledge significantly threatens our industry, which is already challenged to figure out how to match baby boomers with millennials to pass on that knowledge. But the problems facing us go far beyond shortages and speak to the lack of preparedness in addressing the needs of emerging technologies such as advanced air mobility, engineering, additive and advanced manufacturing, and maintenance, repair, and overhaul. Pilots, aviation maintenance technicians, and manufacturing have garnered most of the headlines about shortages. The problem is the public view that youngsters can find more rewarding careers in Silicon Valley and gaming than from the old industrial, aviation, and aerospace industries. With the advent of advanced air mobility, commercial space, and advanced manufacturing, we know aviation aerospace can give Silicon Valley a run for their money any day. We just have to create the tools that get that message across, something that is very high on my agenda. One of the major problems is insistence on college for everyone. For that reason, industry, government, academia must work together to forge new regulations and new training procedures and new academic programs that bring the industry into the 21st century. The creativity of aviation educational institution has been stymied by antiquated federal regulations that have not changed since the advent of the jet age. Compounding this is the failure to change by both regulators and unions. The good news, however, is there is lots of activity to address some of these problems, the most significant of which is the work by the Aviation Technical Education Council, supported by unions, to reform aviation training for AMTs and proposals to create super technicians that work across disciplines. That is complemented by hundreds of industry programs to reach kids as young as pre-K, using aviation and rocketry as focal points for STEM education. These programs, the most prominent of which include Experimental Aircraft Association's Young Eagle program and Aircraft Owners and Pilots Association high school curriculum, are reaching millions of young people. More importantly, many of the education programs are targeted at underrepresented communities, which meet business demands for more diversity and inclusion, which studies show is critical to the bottom line. Complementing this is industry workforce development programs, which work with high schools and community colleges to provide pathways to careers. They are partnering with career and tech ed programs worldwide to create the next generation workforce. The importance of career and tech ed cannot be underestimated because it creates a strategy for meeting ever-increasing college costs. High schools and community colleges have already created train-to-work programs for local manufacturers, and many such programs have far more applicants than they have spaces for students, which means parents are demanding new options for higher education. But this will mean creating really robust college tuition benefit programs on the part of corporate America. While this is already happening, businesses need to sell it as part of their recruiting packages to meet parent demands for college education, especially for those taking advantage of train-to-work programs. I've published a long and comprehensive list of educational programs on the Future Aviation Aerospace Workforce News website and have already updated it 3 times thanks to crowdsourcing. It is designed to connect the dots between educators and aviation education programs and corporate workforce programs and vice versa. To date, I have learned that most are reinventing the wheel rather than amplifying the programs already out there. While many organizations are tackling aviation aerospace career promotion, Academia is questioning how we can meet future demands. We know the emergence of advanced air mobility will severely test how we train and how we do business. One of the first future aviation aerospace workforce news stories focused on how maintenance will change and how aviation must accommodate this change. On-site MRO at the point of origin and destination are sea changes. The challenge is then incorporating new studies in a finite number of hours. For aviation maintenance, such constrictions are gone, eliminating hour requirements in favor of competency-based training and metrics. But that is only one of dozens of issues facing the education of future aviation aerospace workers. We also need to recognize that education is no longer graduating from college or grad school and then on-the-job training. Aviation aerospace education is now a lifelong continuing education job. Future education has to deliver academic programs that meet the new technologies coming at us, and businesses must rethink professional development and make it available right down to line workers. Issues brought on by the emergence of advanced air mobility and vertical flight are complex, and it is past time to jump in with both feet on making changes.
Thank you. That was extraordinary. I think you've covered an incredible number of topics. Let me turn on the camera. Right. Thank you, Kathryn. An extraordinary number of topics. You crammed it in. And you probably mentioned disciplines that were new to many of the audience. Some are aerospace engineers on the design end, some are sustainment, some are maintenance, some are business. And as you discussed, the education doesn't stop with the first hiring. Any other thoughts you'd like to share in the time you've got in terms of what the audience needs to be thinking about as they listen to the other speakers who are practitioners in different elements of the field?
I think only one thing, and that is we all need to be putting our thinking caps on to rethink education, to innovate, and to figure out different delivery methodologies. I just wrote an article in this week's Future Aviation Aerospace Workforce News on some of these issues. And I was really kind of shocked at how many of these issues are out there not being addressed. And the bottom line on many of them, for instance, one person suggested micro certifications, so that we rejigger aviation education into creating short courses, more accessible to the workforce, to create certifications that will ultimately lead to a degree somewhere. And so it's that type of thinking that I think that we need to be embracing, or at least need to be discussing, to find out where are the holes, where are the good parts, where are the bad parts. But I think we're facing a real challenge on rejiggering education to meet the 21st century demands of the workforce.
Excellent, thank you. And when you talk about accreditation, I imagine that Dr. Pruitt and Dr. Leveson, who are going to speak a little later, who both are in academia today, may touch on that, or we can come back to it in the conversation. Thank you, Kathryn, very much. I appreciate that.
You're very welcome.
So we'll move on. Our next speaker, Dr. Mark Robeson, Structures Technology Area Lead, Technology Development Directorate for Aviation, U.S. Army Combat Capabilities Development Command, Aviation and Missile Center. Mark's advertised his discussion as developing the Army future vertical lift workforce. So Mark comes at this from our service customers to protect us. Mark, the floor is all yours.
Thank you, Dan. Good afternoon, everyone. I'm honored to be a part of this, privileged to be a part of this, and looking forward to the conversation and what we can all learn. The vertical flight community is taking innovative new concepts from ideas, from formative ideas all the way to flight, and doing so effectively requires a workforce with a proper mix of skills and knowledge. Academic education in traditional engineering fields remains, and probably will remain for the most part, a foundational requirement, but more breadth is needed for concepts to take flight, literally. Knowledge and skills in areas like design, technology, integration, systems, modeling and simulation, testing, prototyping, and production are just a few of the ingredients needed. Again, I lead structures technology development within the DevCom AVMIC, and within the Technology Development Directorate for Aviation, we do several things that constitute our mission. We manage and conduct basic research, applied research, and advanced technology development. We provide life cycle engineering and scientific support for aviation systems. We mature technology to maintain the relevance of the current fleet, and we develop and mature technologies to support the future fleet. And think of future vertical lift in that context. Successful execution of our mission requires the highest caliber of high-performing subject matter expert professionals, and reaching this level of performance requires an ongoing, very broad education in vertical lift aviation. We prioritize, plan, and document this education while we also allow flexibility as needs and priorities change. We have a continuous learning requirement. We require a certain amount of training a year. We really put an emphasis on ongoing education. What I want to talk about is the scope of education that can really be categorized into 1, formal education, and 2, an informal, in-house, or on-the-job type of education. I want to give a few examples for formal education that we practice and use and leverage in our organization. One of those is the Defense Acquisition University. This is a DoD university that provides the environment to develop qualified acquisition requirements and contingency professionals to deliver and sustain effective and affordable warfighting capabilities. And that's really about getting technology to our customer, the soldiers in aviation. Among early career engineers, DAU coursework constitutes a good bit of their time, with the goal of getting them certified at a journeyman level so that they have some of those basic tools that type of education provides. Another example is the Vertical Lift Research Centers of Excellence. These are universities. This is basically our Army partnership with academia, our primary one. We partner currently with Penn State, Georgia Tech, and University of Maryland as those Vertical Lift Research Centers of Excellence. This strengthens academia's contribution to rotorcraft research and technology, and it educates our next generation of engineers. Several graduates of VLRCO now work for our organization, and we hope that continues. That's an excellent stream of highly qualified candidates. Another example is offered by Penn State University, and they have an annual comprehensive short course in rotary wing technology. We often send a lot of our newly hired engineers to participate in that. It covers a very diverse rotary wing portfolio of topics, and our engineers come back from that course much better informed about the types of technologies required and disciplines needed. We have an analytical tool that plays a big role in our organization called Rotorcraft Comprehensive Analysis System, or RCAS. It covers structural dynamics, aeroelastic stability, vibrations, and loads prediction. It's used throughout the U.S. government, and it's used by large and small rotorcraft designers, manufacturers, academia. And I mention this because it's so critical. We make a decided point to offer regular training in this system, in the software system, throughout the year. Our engineers take advantage of this to stay abreast of the changes and how it can be used. Composite materials. I have a structures background, obviously. Composite materials and structures play an ever-increasing role in future of vertical lift. And we've taken advantage of several composites training classes offered by the National Institute for Aviation Research, or NIAR, at Wichita State University. Very good classes with fundamental concepts, hands-on fabrication, hands-on repair, and a lot more. There also, I want to pivot over to the informal or in-house or on-the-job type of education that we leverage. And again, these are critical from taking for our engineers being equipped to take ideas from very earliest conception all the way through flight testing. We have unrivaled science and technology expertise in Army aviation core capabilities and core competencies. Our technical areas in those fields leverage cross area collaboration and matrix support, particularly with our newer engineers, to give them a better sense and better experience of the different types of competencies required, and that they can leverage. Also critical to our success as an organization is our delegated airworthiness authority that we use for flight testing, for research and development, demonstration, user evaluations, etc. This really enables our local experimental flight test experience and capabilities. And in order to enable that, we have local safety of flight review boards. These boards consider safety, risk, and risk mitigation of these flight test efforts. These boards are comprised of subject matter experts spanning all of our technical areas, and we try to get our new engineers exposure to these, and they become the subject matter experts that enable these safety of flight review boards to make our experimental flight testing capability work and work safely. We have in-house engineering design and analysis, as well as electrical and mechanical fabrication. We try to get our new engineers some experience in these areas, and these are also critical to enabling our flight test capability. We have significant structural testing capabilities and facilities, as well as engine exhaust suppressor testing facilities. We also have ballistics test capabilities and facilities. Again, particularly with our newer engineers, even if they're not going to be working predominantly in these areas, we try to get some exposure to this test capability and these facilities. It not only helps them understand the big picture, but it provides a variety of opportunities that they can leverage in their own areas of expertise. There are wind tunnels that our organization leverages. The folks on my team, for instance, they're probably not going to be working extensively in wind tunnels, but we try to get some of that early exposure available to them so they can fully understand, again, the whole width of, and breadth of what we do and what we need to do. We have a local Army contracting command cell located within our Fort Eustis facilities. We partner with industry, our industry partners, extensively. It's critical to how we operate, and contracting is a part of that. And for our engineers not to understand the contracting side of the house, they're missing part of what they know to make the whole system work. So we have a good partnership with our contracting folks, even though our folks come into the organization predominantly as technical folks. That contracting understanding and relationship is critical to what we do. So those are some examples of the formal education and what I think of as the on-the-job or informal education. And I'll close with a sort of broad question to the audience that and my fellow panelists, that maybe you can foster some conversation as we go throughout this panel. And that is, how can the vertical flight community triad of the government, academia, and industry most effectively divide, balance, and cover, providing the breadth of knowledge and skills needed to bring new concepts to the skies? Thank you.
Mark, that was great. Thank you very much. As folks can hear, the U.S. government Army aviation research, development, delivery, sustainment, and eventually disposition. Remanufacture, sometimes in disposition, has got every discipline included. So Mark's organization is very mature in terms of developing and operating systems in very robust environments. So Mark, you mentioned a lot of really interesting things. You talked a bit about multi-generational, the opportunity for senior engineers to mentor junior engineers, the luxury that comes from a large organization. Later when we discuss, we'll talk about how small organizations can try and capitalize on those same techniques and what opportunities are available to them. So Mark, thank you very much for your time.
Thank you.
Our next distinguished panelist, Dr. Nancy Leveson from Massachusetts Institute of Technology, Professor of Aeronautics and Astronautics. And I think you'll really enjoy her perspective. Nancy.
And the problems I see in engineering design are starting to be in the interactions among the components, that is in the system design and not just component failures. And they're related to the new levels of complexity in our system design. In fact, complexity seems to be increasing exponentially. Partly this is because of the use of software, or probably a lot of it's related to the use of software. And software-intensive systems engineering is very different than most students are taught, if they're taught anything about systems engineering. So what are the implications of these trends for educating engineers? Well, here's just a couple that impact me personally. And the first is safety, because I work in the field of safety engineering. And current safety engineering techniques are woefully inadequate. In fact, they're almost useless. They were created 50 to 70 years ago when our systems were very different than they are today. They can't handle software. They can't handle human factors beyond the trivial. And they can't handle the complexity of our systems today. So what happens is basically the system design occurs usually with any input from the safety group, and then the design is analyzed for safety after the fact. And frankly, the goal seems to be to create a lot of paperwork to somehow convince someone that the system as designed is safe, but not to build safer systems. As I say, I work in this field and I develop safety and cybersecurity analysis techniques that can be used to build these properties in from the beginning. But the biggest complaint I get from system safety engineers in government and industry is that these techniques require that the safety engineers be subject matter experts. Well, duh. I mean, they're not just here to fill out a lot of forms and produce paperwork. I mean, how do you analyze the safety of something if you don't know much about the subject matter involved? What we need to do is stop treating safety as a separate group. It's usually separated somehow from engineering, sometimes with little or no interaction with the designers. And we need to integrate safety into the design and development groups and into basic aerospace engineering education. It's almost never taught at a university. So let's switch to software. Software isn't just coding. People seem to think if the students know how to code, they know something about software. Coding is a low-level skill. It's sort of like saying, the person knows some calculus, so therefore an engineer can build a spacecraft. On the other hand, we can't leave software engineering education to the computer science department because they're not going to learn anything about engineering. Computer science department students don't even usually take any courses in continuous math. And the problem we're facing is managing complex software-intensive projects and also in operating these systems with lots of software in them. We need to develop courses on software engineering using engineering problems and for engineers. A third need, I think, is to increase education in system engineering. The most difficult problems we're encountering are not in component engineering, but in system engineering today, particularly for software-intensive systems, as I say, which the vertical takeoff and lift aircraft of the future certainly will be and actually are today. The complexity of future aircraft is going to make system engineering one of the critical engineering subjects, not just the design of the aircraft itself, but the design of the larger systems, including the social systems in which these aircraft will operate. including air traffic control and collision avoidance and congested urban areas, certification of aircraft, regulation, et cetera. Unless these problems are solved, electric VTOL use is going to be limited. You would keep thinking it's going to be expanded, and I think there's an argument for it needing to be expanded, but we need to solve a lot of change our education in order to produce the tools and the techniques and the engineers and workers that will be able to solve the larger systems problems. That's it. I'm finished. Did I get lost?
Yes, that was great. Thank you very much. I think that there are probably those who are very excited about urban air mobility being commonplace in 2023 who might be a little surprised by your perspective and cautioned, I think. So important to talk about. Go ahead.
Absolutely. I'm doing urban air mobility right now. I've large contracts with NASA to try and figure out how to implement it. And we just don't have tools. It's not going to happen. I hate to say it. It'll happen. Are people going to be able to build electric VTOL aircraft? Of course. We can do that now. Well, we can't. But we can solve the technical problems with batteries and other things. What we can't solve are the problems of keeping these things from crashing into each other, from having them integrate into a crowded urban environment, for and integrate with the other parts of the airspace system. For example, airports that are near cities. And in these areas, how are they going to shift off air traffic control? How are we going to do control the interactions with the police and GA aircraft and all these other aircraft? And the GA aircraft aren't going to be able to spend a lot of money on new transponders or other things. How are we going to solve those problems? It's the social problems that are going to hold us up, not the engineering problems.
Interesting. So thank you for that perspective and look forward to more conversation on this. And with that, thank you. We'll move on to our next speaker, David Segal, Director of Sales Business Transformation at Parametric Technologies Corporation, well, PTC now. His topic, he advertised his presentation as Augmented and Mixed Reality Technology for Workforce Training in Vertical Lift Aviation. And with that, David, I give you the floor.
Thank you. Thank you. I have some slides just to illustrate, to run on the background. No much text, but just visuals. And speaking of PTC, maybe go to the next slide. We just recently changed our name to Power to Create. We indeed, 30 years ago, we started as Parametric Technology Corporation with this 30 years heritage. Right now, when we developing this technology and software technology, software intense capabilities, we actually change it to Power to Create, and not only create in the technology domain, but also create in the social domain, in the people domain. And my talk today is particularly about that technology that facilitates that people communication, augmented reality and mixed reality technology. So we can go to the next slide. Just to briefly say that, those technology corporations that I represent right now, PTC, but also those large companies who are developing enterprise engineering and manufacturing software, we discovering new paradigms to bring our solutions to. And in PTC, we actually, with the big investment of over $1 billion, for the last 5 years, we actually bringing this convergence between digital software that we developed for many years with the physical world, when we capture Internet of Things and augmented reality capabilities and merging them with their digital twins that we know very well how to do them. Because I just wanted to bring some images of how augmented reality really brings and impacts the aviation industry. And particularly when we talk about future vertical workforce training, we all know that technology changed quite a bit how our new generation of technicians and frontline workers, they use technology. So we bring this gaming-like technology to the hands of engineers, particularly right now when mobile devices are widely available. Eyewear devices like HoloLens are widely available. So we bring the context of this digital technology to be overlaid on the actual physical assets, devices. When these digital twins can be streamed into those devices and provide real-time, immediate training and learning to the engineer. So here you can see some kind of images, and you can run those like every 2-3 seconds. I just brought those examples when this augmented reality technology can be used for training and distance learning with the collaboration capability, with expert knowledge capture, when in fact retiring engineers with decades of their knowledge can not only write manuals, how do they perform different procedures, how do they apply their best practices. Nobody actually besides them would not know how to do that. They actually can capture their knowledge in these new technology tools, and with the spatial positioning, when they actually perform, when they work around some areas, technology would capture their efforts, what do they do, and they stream that knowledge into the HoloLens or mobile devices. If we can go to next slide, maybe that would be more illustrative to what I'm talking. When that exactly digital technology can be overlaid on top of the physical objects. This for the expert knowledge guidance or knowledge transfer, and those technology packages can be transferred and as the formal education manuals that would replace any current education material that students need to work. It would be connected to their computer systems that they work. That's happening already. Another area that we targeting our technology is for the remote assistance. When in the distant places, we all use this technology like Zoom right now when we connect. So we have the same technology with ability to stream work instructions and guide actual frontline workers to perform that in any place. They can have a call with the expert who would guide them not only verbally but also visually and practically how to perform some particular operation. We speak that this augmented reality technology is seamlessly connected to different product lifecycle management systems or different systems of record when digital work instructions for assembly instructions, for maintenance and service and repair instruction can be streamed into the devices. Yes, you can see, for instance, this MRO facility when that repair capability is streamed into those eyewear devices or mobile devices. So no papers you can see around the frontline workers anymore. So many different applications we can see, and this technology already in quite a bit in use among different companies that we work with. There are three main subjects with this augmented reality technology. One, first is the visualizing digital information and overlaying it on top of physical assets. And that digital information comes in context of particular operation that technician or engineer need to perform. And also at the same time, the digital information not only streamed from the systems of record, it streams from the sensors of the same device when the technician is about to perform some maintenance or some operation. So the technician can see the sensor information inside of the same stream of digital information augmented, like you can see in this particular illustration. Second aspect, besides visualization, is instruct and guide and educate people what needs to be done. So it's not only, so people get educated by performing operation rather than reading about it, learning about it, or doing some study and then going to the actual shop floor or maintenance floor and performing that operation. So they combining those two efforts in one. And finally, the third capability we have is interactive capability. So the technician can interact with that augmented reality software and perform, for instance, inspections. And when the damage detected, technicians can actually create a work procedure or immediate repair request or order some spare parts from the actual inspection procedure. So the overall performance of many operations are shortened. So we can see when we interact with our customers, we can see that they all say that ease of learning of that augmented reality is very significant. Speaking of safety and remote assistant, we actually facilitating those safety operation, and the same augmented reality technology could alert technicians about safety, and we can incorporate safety procedures along with the work instructions. I have some interesting metric to share coming from some of our key customers who implemented it. For instance, Iowa State with Boeing, they did a study implementing augmented reality. They report 30% faster of the assembly line for technicians. GE Energy reports about 33% faster of wiring a turbine control boxes. GE about 50% faster of the assembly maintenance and repair capability. BAE System, same 30% improvement of the knowledge transfer between their workers. So speaking of technology, this is what our contribution to this future vertical lift education look like. And we have several educational programs, especially in the pandemic time. We enabled our technology free to universities and companies, small companies, to adopt and exercise how that augmented reality can change their procedures. I'll stop here.
David, thank you very much. Very interesting, very exciting. Interesting, especially as you tie it to the Zoom meetings and the COVID, but there's also the opportunity for workers who are very experienced and maybe not even working to consult from a distance. Really interesting. Thank you very much. And with that, we'll move to the fifth speaker, Dr. Igor Cherepinsky. He's Director of Sikorsky Innovations, a Lockheed Martin company, and Igor has yet another perspective. Sir, the floor is yours.
Thank you, Dan, and good afternoon. Thanks for being with us. So next generation workforce, right? It's interesting as we see vertical flight evolve, and quite frankly, as we see in general aircraft evolve, we have to ask ourselves, what do we really see in the future as far as vehicles? How do we want to operate them, right? Because that's really going to dictate what the next generation workforce is going to look like, and what we need to do, right? Our part as industry, your part maybe as students, right? How do we get there? So, I'm not going to rehash too much of the sort of vision, because I believe we all have the same vision, right? Be it, urban air mobility or larger vehicles, we are all imagining these, great vehicles where anyone can really operate them, right? Almost, where there are pilots or there aren't any pilots. These vehicles are easy to fly. They're highly autonomous. They're highly integrated. Obviously, they're very electric. Hopefully, in the near future, they're fully electric. We'll get away from burning fossil fuels. And, it's a great vision. As you start to kind of examine what that really means, you realize that these are very, very integrated vehicles. They're very different than, today's VTOL machines. And in fact, when at first I started, my career some 20 years ago, one of my mentors told me, today's aircraft, and keep in mind this was 20 years ago, right? If you look at today's aircraft, you could almost figure out the functional organization of the company that built that vehicle by looking at the aircraft. And they were right? By and large, if you look at the legacy vehicles, you can almost see who laid them out and how they were laid out, and they were done a lot of times that way because, the groups of people, be it transmission folks, electrical folks, right, were working on them, and then it all got put together, right, and there you go, you have a vehicle. That unfortunately doesn't really work for these new complex vehicles. I was really, it was great to hear my colleagues kind of speak before the software complexity, right, and safety, and how do you now deal with all this when you have this one integrated machine that you can't really tell where the propulsion system starts and electrical system starts, where they're merged, the flight control system, the autonomy system, the structures for, right, we are talking about things like smart structures these days. So what does that really mean for education? And what it means, at least what we are seeing, what I am seeing at Sikorsky Innovations as we try to go design these new vehicles, and I'm pretty sure it's very similar with my colleagues across the board, is that as the students are graduating, they're finding out that even though they chose a particular field of study, right, be it aerospace engineering, be it electrical engineering, right, because let's face it, we have all disciplines, right, participating and building these vehicles. Knowledge across all the domains helps a lot. In fact, in a lot of cases, cross-domain knowledge is required to understand even your colleagues, right, to speak the same language. We're finding that there are some students who are leaving schools with, let's say, doctorate degrees, who have done very, very deep levels of research in one topic. Very frequently actually have, almost trouble fitting in, because yes, they are very well versed on this one thing, but perhaps they don't have as, deeper understanding, or quite frankly, understanding they need to interact with colleagues in even adjacent domains, not to mention, domains 2-3 times removed. So that's really the challenge for the students who are graduating today. So that's sort of the one class of an interesting problem that needs to be addressed. The other, of course, is people who are mid-career, right, who see this transformation happen, quite frankly, right before their eyes, right. Again, speaking, to a few people who do propulsion in my company and other companies, even the companies who build, jet engines today. I can tell you 10 years ago, we had some interesting discussions across the board with folks who make, jet engines, and they said, well, this electric thing is decades and decades away, and yet here it is today. So being able to adapt and being able to sort of continue to learn, right, never stop learning and never say never, right? There are many sayings, but they all pretty much say that, words impossible in aviation have never gone together, right? 1 second we say this is impossible, next second, somebody else achieves it. So just the fact is that you really should keep an open mind in the beginning, right in college, and throughout your career, and continue to learn, continue to adapt, is really a big deal. Now, right, the employers, right, us, the OEMs, the companies, we have obviously a huge role to play in it. I know, from personal experience at Sikorsky, we have actually set up quite a few training programs aimed at people in different stages of their career, because we recognize, first of all, that we have a tremendous talent pool, right? And I know we all do across all the companies in our area and other areas. So hopefully that's true, right? So we have to help these people adapt and see new things. Being able to actually put your hands on some of these things again, right? Not being overly bound by PowerPoint and even these great digital design tools that my colleagues spoke of before me. That's all great, but at the end, right, we all make things that fly. They're physical things, and it's a great benefit to actually go out there and lay your hands, sort of, if you will, on these vehicles, experience flight test, learn, figure out how things work and how you can improve it. So again, I would encourage others as well to set up these training programs that take folks from their early career to mid-career to late career and help them integrate. We also have actually training programs set up for people that we just hired, right? The college grads, because again, as people leaving different universities with different programs, we find that the educational base is there, right? I can tell you that all our colleges and universities do a great job of giving people the basic skills, the basic knowledge, but the level of sort of understanding of integration and, quite frankly, experience with things like flight tests, right? Flying small models, small UAVs, actually varies greatly across the board. So some people have done them a lot, some people don't. So that's the place where we bring folks in. We have several programs where they get their hands on a design, build, and test cycle, with smaller things before they really get engrossed in these larger programs where, they unfortunately end up playing smaller roles just because the program is bigger. But by the time that happens, they have a great understanding of the entire process, so they can relate to other things. So basically, that's current state of affairs as I see it to them. Then over to you.
Excellent. Thank you, Igor. That was fantastic. Again, from an OEM's perspective and what you're looking for and how you're continuing to educate. Thank you. Appreciate that very much. Doing very well. A lot of perspectives. Our final speaker, Dr. Amy Pritchett, Professor and Head of Aerospace Engineering at Penn State University. Amy, all yours.
Okay, I'm excited to be here. Part of my background is working in autonomy and safety, especially where it touches the human factor, and that will color my examples. But my hope here today is primarily to provide the perspective of an academic administrator who's constantly looking at how we should be updating, changing, and adapting our curriculum. So with that, first off, let me give thanks to Mark earlier in his remarks for painting some of the pictures that Penn State has with its short course, its vertical lift and rotorcraft center of excellence and so forth, as examples of things that we are currently doing. But here, moving to the next slide, I'd like to touch on a few points of things that at a high level conceptually I see, especially when we look at the aerospace engineering education. So my first point with this slide is that engineers should not think that there is one easy answer to real world engineering problems. Dan asked me to call out the fact that this is especially important for design. You have not only trade-offs between the different disciplines, the cross-disciplinary thinking as Igor discussed. We also have the fact that sometimes the goals of the design stem not just from engineering and physics, but also from societal needs, some of the societal problems that Nancy touched on. The easy point to take from this slide, and it's true, is that we do not want to be siloed, not just in our curricula and how we train engineers in academia, but reflecting the fact that it's easy to happen across the whole industry. Universities offer college courses within disciplines, to be sure, but aerospace corporations also often create divisions, disciplines, and specialists in different areas as well. A broader organizational challenge that we need our engineers to be able to manage. Further though, not just say that there's an easy answer from one perspective. I'd like to emphasize not making certain our engineers do not come out of our training having experienced the belief that an easy answer is all that is required. Students typically get into aerospace engineering programs by dint of excelling at homework in high school earlier and in freshman courses at college, in which there's one right answer. And it's very clear. It can be written on a short line. The answer is 9.2. And somewhere along the way, especially as they move into the engineering classes from the foundational classes, we have to convince these students that the measure of engineering success is no longer the same measure they had before, that we no longer measure them as successful if they can identify the one right answer in a fairly simple and directed question. Instead, that they can embrace the big and difficult questions. Right, moving to the next slide. I love to give a question like this to juniors, even the first lecture in a class on system dynamics. The bigger the equation, the better. There's usually some gnashing of teeth and wailing about how hard this problem is, how unfair this is. Don't I realize that this is sixth order? And then some student says, well, why won't you let us use MATLAB? And I say, of course you can use MATLAB. Of course you can use another similar system. Computers are your friends. The students lean forward when I say this. Some of them think I'm encouraging them to cheat. Others lean back. You mean I have to use a computer? That's not fair. It's not in the curriculum. So my second point is I think that we still have work to do. And again, it comes from broader views of what engineering is relative to computing, similar to what Nancy was commenting on. Rather than thinking of computing as being a separate topic, something they take some classes in on the side, we can continue to work on pointing out how use of computing, whether it's for analysis, real-time computing, on board the vehicle, system computer-based methods to system design and safety analysis, to recognize that computing is integral to all of our practices. My own work focuses on safety. And with maybe only one exception, I would argue that every aviation accident was caused by human error. I said human error, not pilot error. Maybe the designer didn't understand the potential for cracks to form within the engine, and the maintainers didn't understand or have good guidance on how often to test. And so when the engine blew, we could trace back the chain as a community to where we had lacked the imagination to conceive of what had gone wrong. We had thought swans were right, and when that mythical black swan showed up, we were dumbfounded. I'll point out too that this problem with imagination, especially safety, here I want to be emphasizing that we need imagination and creativity and humility to address safety problems, that this becomes more of a factor as we move to more autonomous vehicles. When the number 2 engine on a DC-10 blew out all the hydraulic lines, a crew of pilots was able to learn in real time how to control an aircraft using only differential thrust and elevator stabilizer. Later, a few decades later, when an engine blew out on an A380, a team of pilots was able to convince the automation to let them land the airplane in a way that the automation designers had never anticipated. However, as we move to more autonomous vehicles, these failures will have less ability to call on the pilots, the pointy end of the stick, to land the aircraft in the future. So my third point then is, as engineers, we need an engineering workforce that can balance our ambition. What did Igor say? To go for the impossible. We need to balance that ambition to push the edge of the envelope, to bring new technologies and systems to bear. We need to balance this ambition with the humility to think about what can go wrong. And being in aviation, moving to the next slide, please. I'll point out maybe we shouldn't talk about black swans. We should talk about Canadian geese. They are bigger than we ever thought could take down an aircraft. And so I put this out as one of the example of adverse events that we didn't have the capability to consider before the accident happened. Accreditation. Kathryn mentioned this in her talk, and I'll follow up. There's some good news and some bad news about accreditation. And my point here would be these points helping industry partners with academia in our discussions about what should we be changing about our curriculum, and our overall methods of instruction. I've strategically copied out important words from the accreditation guidelines. I'll point out that there are things that are hard. It sounds easy. Oh, just add more courses. No, everybody wants to add more courses. And we've hit a hard breaking point here. We have to make hard decisions about what concepts and experience we can vote to be into the credit limit that's allowed onto the lifeboat. The good news is that the text here is copied directly from the accreditation guidelines. The accreditation process itself requires input through an advisory committee, typically involving industry and the professional community, where we're required to seek their input, document their input, and show how we've taken it into account. So point 4, if you're allied with the university and wondering how best to get your input heard, there are some effective ways that you can get your input into our system, and that is shown right here. Dan, I put up a Boeing recruiting poster, but we have all sorts of recruiting events through the years from all sorts of industry, all types of aerospace, and even beyond, with many of our aerospace engineers also being recruited by financial firms that want modelers, by autonomous car systems, and so forth. My point here, point 5, is another way that industry can affect change in academia is through the students. What the students learn at this recruiting event and through internships and co-ops shapes the elective courses, the extracurricular activities they choose, and where a curriculum allows what paths and tracks they select through their program. A compelling consideration as an academic administrator when people suggest new courses, new programs, new directions, is knowing whether or not there is student demand for the new courses and programs. If we build it, will they come? The students are smart. They will tell us what they will come to, what they're asking for, and what they expect, especially when they see a compelling need from recruiters, from industry, from the careers that they want to go towards, defining new curricular directions that we should go for. All right, thank you very much.
Amy, that was great. Thank you very much. And I want to thank each of the presenters. So at the end, you've put up a rotorcraft that some would consider ugly unless, you know, it's picking you up in the threat. It's beautiful. Thank you all. I ask each of the presenters to come back, and I invite our audience, the attendees, to bring questions. Use the question box in the GoToWebinar, and we'll be able to see those questions. In advance of that, first I want to thank Mark Robeson, among the others, but Mark was really the inspiration behind this panel session. And Mark and I worked together with Jim Sherman and Mike Hirschberger, the VFS, to put this together, and I'm impressed beyond what I expected. Thank you each, and thank you all. Start with a couple questions here.
And by the way, you can take my slide down unless we want to keep advertising Boeing this much.
It's okay with me. I'll start with Mark. You know, Mark, you bring more than others to this conversation, the VLRCO, the Vertical Lift Rotorcraft Center of Excellence perspective. It started in the early 80s, NASA Army investment, many more schools capable because of the doctoral candidates, successful professors that have gone many other places, many more schools now participating, still 3 primes, but many more schools. But it's classic vertical flight education. So I'll ask Mark to start and then Igor to step in, because Mark has the perspective as the structures engineer that came out of rotorcraft education. And Igor has talked specifically about other careers that bring incredible value as we move to a new form of vertical flight. Mark?
Yeah, VLRCO has sort of been a double, at least I was going to say a double-edged benefit, but it's really more than that. But two of the main things that really help us out is the research that directly comes from it is so critical. We work with these universities to find common areas of interest it benefits the students. But even beyond that, when the students come into our industry, some of them come to work for the Army, which we love, but even when they go to work for our industry partners or go into academia, we're still involved with them. So it's sort of the gift that keeps on giving. And as you mentioned, it's not just these 3 primes, but there are many other schools. And you mentioned the professors that move to different universities. So it really has it's like an octopus with the tendrils of education growing out, and that it keeps benefiting us in many ways. We're very grateful for VLARCO.
Good, thank you. Igor, I know you had thoughts on other disciplines and careers regarding vertical.
Well, I mean, almost really any discipline, right? We employ everybody, and it's funny, especially lately. You know, I have hired mechanical engineers who mid-career decided that they were much more interested in motion planning, example, right? And they use their knowledge of dynamics to really switch the field and become really interested in motion planning algorithms. And this is back to what Dr. Leveson said. Right? Coding is just a means to an end. Obviously, they picked up the ability to write code, but the fact is their background in dynamics kind of perfectly positioned them for that, right? We have electrical engineers who understood potential theory, got into some interesting parallel processing math, and then decided, hey, you know what, I'm really interested in computational fluid dynamics, and completely switch their specialty kind of halfway through to become CFD experts. So it's really more, what is it you have passion for, right? I mean, the thing about the industry, and we all know it, we work long hours, so the fact is, you really have to love what you do, and the rest will kind of come along, really.
Thank you. So I'll move the first audience question, and I want to not be defensive here because it's and perhaps Igor and I shouldn't answer as OEMs. Alice Krubner asks, I appreciate the complexity, other important aspects of the UAM market space. However, how do you explain that a company like EHang or even Joby is so close to commercialization, and others like Bell, Airbus, and Boeing, with all the power they have, are so far behind? And again, I don't want to be defensive. I got some very strong thoughts on that, but I'll leave that. Perhaps Nancy, you'd like to take that one. Do you have any thoughts? Maybe I put you on the spot, Nancy. Amy, do you want to take that?
Oh, you want me to answer that?
Yeah, I invite you to answer so that we, the OEMs, aren't defensive.
I mean, I'm not an expert on big versus large aerospace companies. I think somebody else has to answer that.
Amy, go ahead.
Yeah, I've been part of some interesting roundtables in the last few years held at the National Academy, sponsored by Jae-Mon Shin when he was NASA Associate Administrator. I was struck how we ended up on 2 sides of the table, depending on whether we were defined by venture capital in Silicon Valley. Yeah, we're going to have flying things going everywhere, and coming to the table wanting aerospace background, or whether we had aerospace background. And from my own point of view on safety, part of it was by whether we have come up through an industry that has gotten weighted down by experience of the things that have gone wrong. The amount of testing, the amount of development, the amount of humility that we have to have. And so I love the verve that these new companies are bringing. I hope that they have a plan for not just certification, but operational approval, which is really hard to get, requires a lot of training, tracking, testing, data of not just the vehicle itself, but the broad operation. And new entrants to aerospace usually are flummoxed when they start to experience how difficult a path that is.
Thank you. Anyone else want to comment? Okay. I think at some level, go ahead.
I was part of a group that created the AUVSI chapter on the Space Coast of Florida. And it struck me that, very similar to what Amy said, is there was this dichotomy. It was the people who really wanted to run full speed ahead on vertical flight and drones, et cetera, and the aviation industry that knows what can go wrong. And so I saw them as knocking heads. You're getting in my way because you're talking about safety. I want to operate. So I think there's this distrust. I don't know if it's still there, but there's this distrust between the people in Silicon Valley who are funding these programs and want to get them in operation by 2022, 2023, and those of us from the aviation industry who think safety first.
Okay, thank you. Our VFS director, Nancy, go ahead.
So I guess I do have something to say. Yeah, I can build something that flies, but can I get it certified, as Amy was talking about? Is it going to be safe? Is it going to be maintainable? Is it going to be work in a standard operational environment? There's a lot of other things besides just getting something to fly. That doesn't mean that doing it quickly, and these small companies can't do things quickly. It's really easy to produce software quickly. It's just, and it works 99% of the time. It's just very hard to get it to work 100% of the time. And it's not just a matter of showing, yes, look, I can demonstrate this, it flies. But will it fly the 10th time and the 15th time? And
I would just end, and as a facilitator, I get this luxury to point out that the big companies are concerned about every point in the envelope and not just a few of them. So that would probably be a characterization of why we're conservative versus why Silicon Valley is so optimistic. Both perspectives have some level of validity, and as Kathryn said, it shouldn't be a competition, it should be a collaboration, and mistrust of each other is probably a big barrier. So I'll move on to the next question by our VFS director, to Mark and Amy. What is more important to get more eVTOL and rotorcraft engineers into the field, more money at existing of the 21 universities to build up centers, or expanding to more schools diluting the centers? That's for the Rotorcraft folks with engagement with Rotorcraft centers, Amy and Mark. Amy?
I was waiting for Mark.
Mark, go ahead.
I don't have the answer, but I think it's almost a bit of a self-balancing equation. I think if you pour too much water in the cup, it overflows and finds another place. And I think we've seen that with some of these companies, with some of these relationships that we have. The VLRCO is a good example. A lot of money has been put into each school, and each of these primes does tremendous research. But as the budgets find a way to right size themselves, sometimes they reach out and bring additional schools in. So there's a way that this is expanding to additional universities. So I think the question is finding its own answer, and I think the system has been working well. I can think of at least, in addition to the 3 primes we have in VLRCO, I can think of at least 3 or 4 other schools that have involvement, and they're all doing good work. And I think we're doing that without diluting what we need to achieve. And certainly we're considering the important areas. eVTOL is one of those.
Thank you. Another question from the audience, Melissa James. It's a general outlook question. Will engineering always be a 9-to-5 job, or are you seeing opportunities for a potential shift in the landscape of contractors, consultants, and full-time employees in the coming years, considering COVID or not, curriculum changes, etc.? So let's start with David, who brought up COVID and remote participation and virtual and augmented reality to first address Melissa's question about 9-to-5.
we do see that engineers will be given more freedom to apply whatever knowledge, what Igor actually mentioned, whatever they love more. And right now, that abundance of different technologies available to engineers, and what the paradigms change right now with the ability to work from almost everywhere. And in fact, our particular effort to enable engineers to work with maybe with very sophisticated tools, simulation tools that require like a very high intense computing resources that typically done in offices right now, with adoption of the cloud technology, SaaS technology, those tools can be available in the home office that all of us now speaking from, right? And I can share with you just during the pandemic, we made our software, very sophisticated software, free of charge, and we just hit the mark in educational space. We have more than 1 million users using our software for computer-aided design on the SaaS and modeling capability, which is quite with very rapid pace. They adopted that technology intuitively. So to that question, I do think that we can see that flexibility of contractual work for engineers, less being held into the kind of boundaries of companies, and more agility of their work will be trending.
Thank you. So my next question, typically when you say workforce, people will think of education and school and the first employment and trying to get into the workforce, and they know they want aviation. And I invite the community to think about expanding that later, which is how do you educate or re-educate? And as Nancy says, there has not yet been education in certain fields. How do you educate throughout the career? But more importantly, how do we go earlier? How early should aviation, should we target kids who have an interest in aviation with education versus excitement versus real world challenges? What's, is STEM going early enough? Should we be working with Fisher Price? Amy?
Yeah, one observation that my local, that the Penn State outreach office has had for me is that when they try to make STEM exciting, when they try to make outreach exciting for elementary kids, for middle school kids especially, they call it science, but it's really engineering, building things. And the building things may include the paper airplane, the balsa airplane, the drone, and that's great. The nation overall has a problem with getting enough people into engineering. Whatever we're doing for outreach is not helping. I have a middle school girl, and I'll say that the science curriculum in middle school is not helping. It's not helping inspire her. And I've wondered if there's more we need to do with the curriculum in addition to sponsoring extracurricular. Another thing that greatly worries me is the diversity of the workforce. We are losing a lot of women in middle school. Mm-hmm. And we are losing a lot of minorities in high school around are they being prepared? Are they being advised and guided into the right courses and into the right college programs? And so there may also be things that we should be doing perhaps with the people who are helping high school kids make their college application decisions. With this, I was fascinated, seated with a bunch of women newly admitted to Penn State, indicating an interest to aerospace at a dinner. I thought they would ask me about what it's like to fly an F-18, but instead they asked me, do you have international study programs? And when I said, ooh, that's kind of hard to fit in with our program, they went, oh, where's the mechanical engineering table? So, so we should recognize that one can love aerospace, but they might also love international programs. They might love dual majors. They might love a new and fresh perspective. They might love computers and not want to feel like the computers is a poor cousin that's on the side of the curriculum. And really recognize that if we want a diverse workforce in every way, including diversity of thought and of interest and of discipline, that we need to help accommodate that in a way that goes just beyond looking at what courses are in an aerospace degree.
Thank you. Excellent. Kathryn, you had something you wanted to say on that?
Well, I was in my story that I did this week. I linked to a study that showed that inserting aviation into preschool contributes to higher executive function. So they were saying that it's never too early to apply that. But I think that what the industry needs to do is take the programs that I've listed in all of my in the aviation education resources for aviation and aerospace and amplify them. And one of the things I've heard very many times about what Amy just discussed about losing girls in middle school, losing a diverse population in high school. And that's where also industry comes in, because if we can match mentors with these students to bring them along to increase their interest or retain their interest, they're much more successful. And programs exist out there. Organization of Black Aerospace Professionals has a huge program. They're all listed there, and all we have to do is call them up and say, how can you help us keep our girls and our diverse populations involved?
Thank you very much. So I've got one more question, and then I wanted to ask the panel something. So quickly, if someone wants to take this, from David Kwok, education and training takes time, which means lagging the power curve. Then should we investigate to reduce the lagging interval, ? Or even better, to look ahead and training, educating our future workforces? I'm not sure if I think you've addressed that in terms of the kids in STEM. It shouldn't just be the women engaged in that conversation, the men have to help. That was a comment from Danielle McLean. So this has been great, and I just want to wrap with one question. And Mark actually touched on this when you said the cup runneth over. Too much funding isn't always a good thing, right? So you have to right size the investment. But I'm just going to go through the panel and ask you, if you had, if we were well resourced and President Biden and his administration were to give you, $400 million now to go invest to fix this problem, off the cuff, I'm going to ask each of you just to think about it for a second. I'm going to poll the group. Where would you think you would spend it? Mark, where would you invest first if you could do something right now?
Early education tends, in my experience, from my perspective, tends to be academic and lack application. I would love to see. I mean, we're talking about bringing STEM to elementary, junior high, high school students, or if you think about undergraduate students, it's traditionally been heavily academic. I would love to see some practical applications, some hands-on, some end product, some helicopters, for a big example, being exposed earlier in the education process, not only for that bigger picture, but for that excitement. Because what we do, I think it's fun. I think it should be fun, and part of that is bringing the fun into the academics, because academics are not always fun.
Thank you, Mark. David, quickly.
So if we put it in context of urban air mobility industry, or eVTOL, which is emerging industry, which is the social acceptance is still ahead of that industry, and many different challenges beyond just technology. So I would invest, and it's clear that this industry would provide a lot of benefits to the society and the environmental aspect of it.
Not why, where? Not why, where? Where should we invest?
So I would invest in the more adoption of the benefits of that industry, the promotion of the social acceptance, along with that. Technology will take that course anyway. There is always a venture capitalist who would invest in this, but the really takeoff of that industry depends on their city line, all the smart cities adopting all these aspects, and conversion of that new technologies into large urban areas, which is a great challenge that we all talk about it, but there is very kind of lack of practical programs who would at least would create the actual path how to address that. That would be my area.
One more, Nancy.
All right, well, I agree with Aloy. I agree with Amy about most things. But it's even worse than just she said. We used to have something at MIT called the Engineering Systems Division, which is may become the MIT. And it wasn't just engineering, it was social sciences, it was management, and it was a division where we encouraged people to work on these very large problems together from all these different perspectives. We're not going to solve the problem from one perspective. What we need to do, and it got killed, by the way, mostly because the individual professors thought this was somehow a threat. They didn't need this. Some people weren't participating. But we're not going to solve these large societal problems until we get all kinds of perspective, not only science and engineering, but management, social science, economics. All of these things are all intertwined. And that's, I think, where we need to go if we want to make great progress.
And with that, sorry I can't take any more answers. I thank you all. I think it has been fantastic in terms of perspective. I invite the audience to get in touch with us. We remain interested in this topic. Perhaps this workforce panel will lead to something more. Jim, back to you.
All right, thank you, Dan. Maybe one of the things we should stop doing is advertising engineering as a 9-to-5 job. In my 25 years or so, I've never worked a 9-to-5 job, ever. I've worked 6 to 6, I've worked 6 to 3 a.m., I've worked 11 p to 11 a, but never 9 to 5. Anyway, that's just me. Thank you, Dan. Great job pulling this panel together. Wonderful job, speakers, and providing outstanding differing viewpoints. This is definitely an issue that VFS has a great interest in, especially with VLR codes and all the academic and government interactions that we have with industry. So we'll continue to push this topic along. So thanks again to all of you.